I'm talking, my basic definitions I've typed up for you. And in fact, every problem we're gonna do tonight, I have typed up how to do it. I'll talk through them. So you can kind of add to your notes instead of having to write everything down. It'll go a little quicker. Okay, so in physics, what is meant by work is the product of force times distance. Force times distance. Forces in the SI system, so the SI system is the metric system.
Mm-hmm.
The unit of force in that system is a kilogram times meter per second squared. Because you're taking mass and you're multiplying by acceleration. And so in the SI units, the unit of force is kilogram, which is mass, it's mass times acceleration. That's one of Newton's laws of motion, right? That's one of the, I don't know which one it is, but it's one of them. I'm sorry, what, Dustin?
Second law.
The second law, thank you very much, to say, it's the second law. So the kilogram is the mass and the meters per second is the acceleration. Because, I mean, who knows why, but I mean, that's a kind of messy unit to write down. So it is also named after a physicist whose last name was Joule. And so the unit of joule means the same thing as kilogram times mass per second squared. And, Newton, a Newton is a kilogram times mass divided by second squared. And then the distance we're gonna use is meter. Okay, so this is your mass times acceleration, but then you're going to multiply that by your distance, and in the SI system, the distance we're going to use is meters. And so this is a Newton meter. That is also called a joule. Okay, so a Newton is a unit of force. The definition of work is force times distance. So when you take a Newton of force and you multiply it by a distance, you get units of Newton times meter. That's also called a joule. In the English system, so we still generally operate using miles and inches and yards and so forth. In the English system, the force is in pounds and the distance is in feet, and there's no special name for it. Okay,
it's called torque.
Well, it is torque if you are
Rotating.
Yeah, if you're rotating, yeah. And for whatever reason, even though this definition is force times distance, and we know that the order that you multiply doesn't matter, but if people state the definition of work, they're going to say force times distance. But the unit, we will say foot pounds. Okay, we don't say pound foots or pound feet or whatever. We say foot pounds. So I guess it sounds better. I don't know, but anyway, this is in the English system. You're going to see the unit written in foot pounds. But technically, I mean, you can use any units you want. I mean, if your distance was in inches, I mean, you could have inch pounds. I mean, mathematically, it's okay to do that as long as you're putting your correct units. One thing to keep in mind, and as we do problems, this will come up, but again, we measure things generally in terms of pounds. But for example, if you go to an airport, because especially an international airport, they may tell you that your bag can't weigh more than 25 kilograms,
Yeah.
okay? They're stating a mass, they're technically stating a mass, even though they're talking about a weight. And so just, be aware in terms of our vernacular, people use kilograms to represent a weight, but technically kilograms is not a weight, it's a mass. So kilograms is really a mass. It's not a weight, even though we use it at times to represent weight. It's like we say, well, it would be the weight if you multiplied by acceleration due to gravity. So when in these problems, and in any physics problem, if you are working with kilograms, but you really want it to be the force of the weight of the object, you have to multiply your kilograms by acceleration due to gravity. And so that is, again, the negative is only relative. If most of the time you're going to count down as a negative direction, but technically you could change that as long as you're clear about the fact that you've altered your directions. But the negative is indicating the direction. Gravity is pulling down toward the center of the earth, and it's negative 9.8 meters per second squared. So in these problems, and in any physics problem, if you really want weight and you're given kilograms, you need to take your kilograms and multiply it by negative 9.8 in order to actually get the true weight, the true force that would really be its weight. All right, so I'm kind of ahead of time just kind of going over that so that when we start to do problems, we don't have to have this whole big discussion. Okay, so example number 1, we have a weightlifter and he lifts 60 kilograms from the floor to a height of 2 meters. So the force that is being applied is the 60 kilograms times 9.8. Now notice I left the negative off because we're just wanting to look at this as a force, and we're not, the direction doesn't matter right now. Okay, the direction doesn't matter. So 60 times 9.8 is,
That's what it says.
no, it's,
That's what it says on
oh
the
yeah,
paper.
yeah, okay, yeah, thank